And so we'll get started here on homework 3, still working with fractions. Yes. Oh, okay. Yep. So first one's here, we're going to write an improper fraction as a mixed number. An improper fraction means the top is bigger than the bottom, the numerator is bigger than the denominator. And really, they're checking to see, do you understand what a fraction is? Fractions are really just division problems. 20/7 means I'm going to take 20 and divide it by 7. And so to write that as a mixed number, I'm going to do division. 7 divides into 20 2 times. 2 times 7 is 14. If I subtract there, I have 6 left over. So 2 6/7 is my mixed number. Oops. Now, if you have your calculator handy, we said yesterday or whatever day we were working with our calculator, that on the calculator the default is to put them in as a mixed number. So if you enter your improper fraction in, 20, hit the fraction button, 7ths, and you hit equals, the calculator is going to do the mixed number 2 6/7. So number 2, if I'm going to write 16/9 as a mixed number, again, I'm just dividing 16 divided by 9. 9 divides into 16 how many times? Just once. And then if I take 16 minus 9, what do I have left over for my remainder? 7. So 1 7/9. I'll sneak it in here. You can read it then. 1 7/9. So go ahead and do 19/8 there on your paper. See what you come up with. And so, when you do 19/8, 8 divides into 19 how many whole times? 2 times. Because 2 times 8 is 16, and the remainder is 3, so 2 3/8 exactly. 2 3/8. Now, if I'm going to go the other way around and write my mixed number as an improper fraction, what I'm doing is I'm taking that whole number 2 and thinking about how many pieces I would have if I divided each of them into 7ths. So if I had 2 circles and I divided each of them into 7 parts, 1, 2, 3, 4, 5, did I get it? 1, 2, 3, 4, 5, 6, 7. And same thing here. They should be even, but close enough. I'm not very good at drawing. I would have 14 pieces altogether if I divided each of my circles into 7 parts. So the 2 is really 14 pieces. Then I have the 4 that I have up here that I have to add on there. I'm going to get rid of my circles that I drew, or whatever shape that was. So your process here is what you're going to do is you're going to take the denominator times that whole number. 7 times 2 is the 14. You're going to add the numerator, which is 4. And the denominator is not going to change. I'm still working with 7ths. So here's my 14 plus the 4 that I had. So 18/7 is going to be what my improper fraction is. Now on my calculator, if I put in 2 4/7, I'm going to hit the fraction button between the whole number and then also in the fraction. So it looks kind of weird, but I'm going to do 2 fraction 4 fraction 7ths. And when I hit equals, it doesn't really look like anything changed on my calculator, right? If I want to change that to an improper fraction, we talked about that the other day, when the calculator gives you the mixed number, you hit shift and the fraction button. Shift and the fraction changes your mixed numbers into improper fractions, and it says 18/7. So if I'm going to write 3 8/9 as an improper fraction. Here's what I'm thinking in my head. I'm going to do 9 times 3 first. 9 times 3 is 27. And then I'm going to add the numerator. So 27 plus 8. Is 35/9, exactly. I'll write it out so you know what I was doing in my head. So, go ahead and try to do 3 2/3 as an improper fraction. You get 11/3, exactly. 3 times 3 is 9, plus the 2 on top is 11, and my denominator's in thirds, so 11/3. Adding, and well, we're just doing adding mixed numbers, we're not going to subtract yet, we're just going to add mixed numbers. When we add mixed numbers, I like to line them up so that I have one right on top of the other one. 5 8/9 plus 6 4/9. Because really what we're going to do is we're going to add the fraction part first. If we need to rewrite that as a mixed number, we will. Then we're going to add the whole number parts together, and then we're going to take our two answers and put them together. So, first of all, just adding my fractions. They're already both in ninths. If I take 8/9 plus 4/9, I would get 12/9, right? 8 plus 4 is 12. So I have 12/9. 12/9 I can simplify. First of all, I can reduce it down, right? 12 and 9 are both divisible by 3. And I would end up with 4/3. Now 4/3 is an improper fraction, so I can rewrite that as a mixed number. 4/3 is a mixed number. If you just think of it in your head, you're dividing. 3 divides into 4 one whole time with how many extra left over? 1. So 1 and 1/3, right? Now if I add my whole number parts, 5 plus 6 is 11, right? So now I'm going to take that 11 and add my 1 and 1/3. 11 plus 1 and 1/3 is 12 and 1/3. I just wrote everywhere. So, if for fun I wanted to check that with my calculator, again, to do my mixed number, I'm going to hit the fraction button after the whole number and in the fraction. So I'm going to do 5 fraction 8 fraction 9. 5 8/9. Plus 6 fraction 4 fraction 9ths. And then I'm going to hit my equals. And it says I get 12 and 1/3, right? Now see on this one, remember the other day it kept saying write your answer as a fraction in simplest form? These ones say write your answer as a mixed number in simplest form. So yes, these ones we are going to leave the mixed number answer. We're in homework day 3 if you didn't figure that out already. So number 8, if I'm going to add those, I'm going to start and I'm going to add the fractions together. So 7/9 plus 5/9. 7/9 plus 5/9 would be 12/9 again. Hey! So just working with that fraction part of 12/9. I like to simplify it first. You could change it to the mixed number first, but I like to reduce it first. So if I reduce that down, I can again divide that by 3. And I get 4/3. And then I can change it to my mixed number. 3 divides into 4 one time with the remainder of 1. And 1 and 1/3, we did that on the previous one, so I don't think we need to do it again. Adding our whole number parts. 9 plus 6 is 15. So I'm going to do 15 plus my 1 and 1/3, and I'm going to end up with 16 and 1/3 for my answer. So go ahead, try to add number 9 there on your paper. So what did we get? 13 and what?
1/5.
And 1/5. Okay, let's see if we get that. If I take 9/10 plus 3/10, we get 12/10. 12/10 can be reduced down to 6/5, exactly. 6/5 as a mixed number is 1 and 1/5. And then if we take 8 plus 4, we get 12. 12 plus 1 and 1/5. Hey, we all know how to do that one. All right. Subtraction of mixed numbers with the same denominator and borrowing. These are the ones people sometimes have trouble with when you have to do the borrowing. So again, I'm going to rewrite this first one this way. 6 and 4/9 minus 4 and 7/9. Now, the times you have to borrow when you subtract is when your top fraction is smaller than your bottom fraction. Because if I subtract, I have to try to take 7 away from 4. Well, I can't take 7 away from 4. I don't have enough on the top. So what we end up doing is having to borrow 1 from our whole number. I'm going to borrow 1, which makes the 6 a 5. But when I borrow that 1, I want to think of it like I did that circle the other day. I want to be in ninths. 1 would be equal to 9/9. So when I go over here, when I borrowed my 1, I'm going to add 9/9 to my 4/9. 9 plus 4 would give me 13/9. If you think about 13/9 as a mixed number, 13/9 would be 1 and 4/9. Now I can go ahead and do my subtraction because now I can take 7 away from 13. 13 minus 7 is going to give me 6/9. Now we always know we want our fractions in simplest form, so again we'd want to reduce it down. Those are both divisible by 3, so that's going to give me 2/3. Then I can go back over here and subtract my whole numbers. This one I changed to 5. 5 minus 4 is 1, so I'm going to get 1 and 2/3. Again, if you wanted to check it with your calculator, you'd do it just like we did the ones where we were adding, hitting the fraction button between your whole number and the fraction. So 6 fraction 4 fraction 9ths minus 4 fraction 7 fraction 9ths. And I get 1 and 2/3. So if I look at number 11, I'm going to take 7 and 1/9, and I'm going to subtract 3 and 7/9. Fortunately, my computer wasn't very creative, and I'm in ninths again. But the same kind of thing. I can't take 7 away from 1. So if I'm going to try to subtract here, I'm going to end up borrowing. I'm going to borrow 1 from the 7, which would make it 6. And then I'm going to add the 1 to my fraction in terms of ninths, since my denominator's in ninths. So I'm going to add 9/9 to my fraction, which makes it 10/9. And now I can subtract. 10/9 minus 7/9 would be 3/9, right? And 3/9 can be reduced. 3/9 would reduce down to 1/3, 1/3. Then subtracting the whole numbers, 6 minus 3 is 3, so 3 and 1/3 is going to be my answer. So, 12, they changed the denominator. Let's see if you can figure that one out. Go ahead and give it a try. Got your answers? What you get?
3 4/5.
3 4/5. Good. That's what I got too. Here, when I borrow 1 from my 5, I have to add 10 tenths because that's the unit I'm working with. So 1/10 plus 10 tenths is 11 tenths. 11 minus 3 would be 8 tenths. I'll write it over here. 8 tenths can be reduced down, so we would have 4/5. And then the 4 minus 1 would be 3. So we got 3 4/5 exactly. Number where we are, 13, that's where we're at. Now we're going to add when we don't have a common denominator. Same kind of thing. I want to do the fraction part first, and when I do the fractions, I have to have a common denominator. So this one's 5 3/5. I'm going to add 5/6, but on my fractions, I have to find my common denominator. Here, since I have a denominator of 5 and a denominator of 6, my common denominator is going to be 30. And I'm going to make my equivalent fractions. 5 goes into 30. 6 times 3 is 18. 6 goes into 30. 5 times 5 is 25. So now I'm going to go ahead and add 18 plus 25. 1343, huh? 43 thirtieths. Now 43 thirtieths I can't reduce, but then I'm going to rewrite it as a mixed number since I'm working with mixed numbers. If I divide 30 into 43, it's going to go one whole time, and I'm going to have 13 left over. If I need to do long division, I'll do long division, but I can subtract that one in my head. So I get 1 13 thirtieths. Here I just had that 5, I didn't have anything to add it to, so that's just going to be 5 plus my 1 13 thirtieths, so I'm going to get 6 13 thirtieths for my answer. And same thing, if I wanted to check that one, I'd do my mixed number, 5 fraction 3 fraction 5, 5 3/5, plus 5 fraction 6, and I get 6 13 thirtieths. So on number 14 it says add 7 3/4 and 6 5/6. I'm going to add the fraction part first. I don't have a common denominator, so that's where I'm going to start with my common denominator. If I have a denominator of 4 and a denominator of 6, my least common denominator is 12, exactly. 4 goes into 12 3 times. 3 times 3 is 9. 6 goes into 12 2 times. 5 times 2 is 10. So 9 twelfths plus 10 twelfths, 19 twelfths. Again, I can't reduce that fraction down, but I can rewrite that as a mixed number. What would 19 twelfths be as a mixed number? 1 7 twelfths. Right? 12 goes in there once, and then if I subtract, I have 7 extra left over. Adding my whole numbers, 7 plus 6 is 13, so 13 plus my 1 7 twelfths is 14 7 twelfths. All right, go ahead and do 15 there.
Huh. I went all the way to 19.
Did the copy machine skip that page when I ran it through the copy machine?
So I went from 14 to 19 on the back.
14 to 19.
Yeah,
Let's do this. File, print. We don't need the whole thing, we just need the current page. And I'm going to print 6 copies. Sometimes the static gets it together and it doesn't feed through the typing machine right. Now let's wait for the printer to wake up. While we're waiting for the copy machine to print there, you can pop over on Alex and see if you have any of those first ones we did. Oh, it's faster than I thought it would be. Quick time to take a long time to warm up. One, two. Oh, you must have been on your report instead of on the pie chart. Because it just showed you an example problem instead of the actual thing. So it's here on your report, so you go down to the bottom and hit done.
Oh,
Now you can try number 15. Now that you have number 15.
Well, Linda, since you're on this and I'm on this, but
So, that's right. You changed it 2 and 3/3, and now you're going to take away 1 and 3/5, right? So now you're going to find your common denominator and do all that good stuff. Oh, wait a minute. I want to do this instead. Instead of doing 3/3, what do we want our denominator to be?
5.
So let's use 5/5 instead. Not that the other wouldn't work, that made it shorter.
But it's still the same thing, right?
Yep,
Okay.
because now I can just subtract.
1 5 5.
Yep, exactly.
Makes sense.
Oops. All right, did we get an answer? What'd you get?
4 and 5 18.
All right, good. So here my common denominator is going to be 18, like I said. 6 goes into 18, 3 times 5 is 15. 9 went into 18, 2 times 4 is 8. If I add that, I get 23/18, which can't be reduced, but can be written as a mixed number. 18 goes in there once, with 5 extra ones left over. Here I had 3, so 3 plus 1 was 4, and 5/18 then. Exactly. The next one there, 16, says we are going to subtract with different denominators and borrowing. So combining those two things we did, same kind of thing. I'm going to do 5 and 1/6. I'm going to take away 2 and 1/4. But I have to have a common denominator when I work with fractions. So I'm first going to do my common denominator, which would be 12. 6 goes into 12. 2 times 1 is 2. 4 goes into 12. 3 times 1 is 3. Now we have like our previous subtractions. I can't take 3 away from 2, so I end up having to borrow. Now you don't have to borrow on every single subtraction problem. They just give you these ones because they're harder to do. If this was 5/12, I could subtract right away. But I can't take 3 away from 2, so I'm going to borrow 1 from the 5 and make it a 4 and add 12/12 to my 2/12. So I get 14/12. Now I can subtract. 14 minus 3 is 11/12. 11/12 I can't reduce down. I'm just going to leave that so I can do the subtraction on my whole number. 4 minus 2 is 2. So 2 and 11/12. So if I look at the next one, I'm going to take 9 2/5. I'm going to subtract 3/4. So on that one, my common denominator is going to be 20. 5 goes into 20 4 times. 4 times 2 is 8. 4 goes into 20 5 times. 5 times 3 is 15. So if I take 8 plus 15, I get 23. So I have 23, or 8 plus 15. I'm subtracting. I'm trying to add. Gosh darn it, I better look to see what I'm doing. I am trying to subtract. I can't take 15 away from 8, so I have to borrow. I'm going to borrow 1 from my 9 and make it 8. And I'm going to add what to my 9/20th, or my 8/20ths? 20/20ths, which makes it 28/20ths. Now I can subtract, because that's what I'm supposed to be doing. 28 minus 15 is 13. So 13/20ths. That is in simplest form. I can't reduce it. And I have an 8 over here, and I'm not taking away any other whole number. So I'm just going to get 8 13/20ths. So go ahead and try number 18. And we're coming up with nothing yet. You're still working?
Three and 13/24.
All right, good. 3 and 13/24. So that's what we should come up with. My least common denominator of 8 and 6 happens to be 24. 8 goes into 24 3 times. 3 times 3 is 9. 6 goes into 24 4 times. 4 times 5 is 20. I can't take 20 away from 9, so I end up borrowing 1, making that a 7. So I add 24/24 to my 9, and I get 33/24. 33 minus 20 then is 13/24, which I can't reduce, and 7 minus 4 is 3. So exactly, 3 and 13/24. Now, when we work with adding and subtracting of mixed numbers, we do it a whole different way than when we do multiplying and dividing mixed numbers. With multiplying and dividing of mixed numbers, you have to change your mixed numbers into improper fractions as your very first step. You could do it with adding and subtracting, but then your numbers get really big. So that's why we usually don't on adding and subtracting. But on multiplying and dividing, we do have to change them into improper fractions first. So we're going to take the 5 times the 2 is 10, 10 plus 1 is 11, and we're going to make that 11/5. And then we're going to multiply here. 9 times 2 is 18. 18 plus my 7 is going to give me 25 ninths, right? Now we're going to do our multiplying like we did multiplying the other day. If we can reduce, we want to reduce first. We can reduce the 5 and the 25. 5 goes into here once and into here 5 times. The 11 and 9 don't have anything in common, so we can't reduce those. 11 times 5 is 55. 1 times 9 is 9. Now again, if we look at the directions, we want to write our answers as mixed numbers since we were working with mixed numbers, and so we want to change that into a mixed number. 9 divides into 55 how many whole times? 6 times. 6 times 9 is 54, so we just have 1 left over, so 6 and 1/9. And the multiplying on your calculator is pretty much like the adding and subtracting was. We just have to make sure we hit that fraction button between our whole numbers. 2 fraction 1 fraction 5, 2 and 1/5, times 2 fraction 7 fraction 9ths. And if I hit equals, I get 6 and 1/9. So again, my suggestion, work them out paper, pencil, check them with your calculator. That way you know how to do them both ways. Number 20, we're going to multiply again. Here, this is already a fraction, so I don't have to do anything with the 2/3. But I have to change my 2 and 4/9 into an improper fraction. So, what would 2 and 4/9 be as an improper fraction? 20 what? Okay, try that again. 22 over 9. 9 times 2 is 18. 18 plus 4 would be 22 over 9. Oh, they didn't make this one very nice. I can't do any reducing, can I?
You can't?
I
With
can't.
the 2 and the 22, or does it
No.
have to be crosswise?
It has to be one on the top, one on the bottom. It
Okay.
actually could be up and down, but then your fraction would, you could reduce, you know, if you had 4/6.
Okay.
It'd be kind of silly, but you could do it that way. But one on the top, one on the bottom, usually they're across from each other.
Okay.
But in this case, I can't reduce the 2 with the 9, I can't reduce the 22 with the 3, so I'm just going to multiply. 2 times 22, 44, 3 times 9, 27. I now have to change that into a mixed number. 27 divides into 44, how many times? Just once. And so if I take 44 and I subtract 27, I get how many left over? $17. So 17 27ths. So 1 and 17 27ths would be my answer as a mixed number. So go ahead and try number 21 there on your paper. Are you not getting the same thing?
Usually not. 28 times 12? It just seems like...
It is a big number, but did you look to see if you could reduce first so your numbers weren't so big?
Oh, okay.
Because I can do a little bit of reducing there, right? Or maybe a lot of reducing. All right, it's looking better. And what are we coming up with for an answer? 5 1/3. 9 times 3 is 27, plus 1 is 28 ninths. here. 1 times 7 is 7 plus 5 is 12 sevenths. Here I can reduce both ways. 3 goes into 9 3 times and into 12 4 times. 7 goes into 7 once, but into 28 4 times. And so 4 times 4 is 16. 3 times 1 is 3. So I have 16 thirds. And if I divide 3 into 16, it goes in there 5 times with 1 left over. So 5 and 1/3. Now if you forgot to reduce here, you should be able to reduce here. It's just their numbers are a whole lot bigger, and so it's not as easy to do, right? So if you check your reducing, makes it a lot easier. 4 times 4 is a lot easier than 28 times 12. All right, what did I do there? Those are not mixed numbers. Shh. I must have gone crazy. I didn't type this page. I think my helper did. She was doing introductory algebra. Those aren't the right problems. Let's find some new problems to write on our paper. Let me log into Alex and we'll find some examples. Want me to log in? Get in here where I want to be yet. View mixed number division. That's where we want to be. All right. So, scratch off the one on your paper and make it this problem. 6 3/4 divided by 1 7/8. Again, we're dividing with mixed numbers, but when we divide, we end up multiplying, so we have to change them into improper fractions first. So 4 times 6 would be 24. 24 plus 3 would be 27/4. This is still dividing. Now I'm going to write that as an improper fraction. 8 times 1 is 8. 8 plus 7 is 15, so 15/8. Now that I have it written down as dividing fractions, we follow the rule for dividing. When we divide fractions, we invert that second fraction and multiply, right? Multiply by the reciprocal. So we change our problem into 27/4 times 8 over 15, right? We flip that second fraction. Then I look to see if I can reduce. Well, 4 goes into 4 once and into 8 2 times. The 27 and the 15 are both divisible by 3. 3 goes into, oh actually they're both, no, 3. I thought it was going to do more than that. 27 divided by 3 is 9. 15 divided by 3 is 5. So now multiplying, 9 times 2 gives me 18. And 1 times 5 is just 5, so I have 18/5. Now this one says, write your answer as a fraction or a mixed number in simplest form. What they mean by that is if it's a proper fraction, you're going to leave it as a fraction. But if you get the improper fraction, they want you to change it to the mixed number. So we're going to change this one to the mixed number. 5 goes into 18 3 times. 3 times 5 is 15. And I get 3 left over. So 3 3/5 should be our answer. So, now when you put your mixed number in on Alex, if you type your whole number first, whoops, if I click up there to type, 3, and then click this button here, I can do 3 tab 5 and get it in there fairly easily, 3 3/5. And now we'll find out if we did it right. Hey, we did. Oh, it says I want to be done. Now I need some more practice. Okay, so we're going to do on the next one. Scribble the next one out. Do 3 1/6 divided by 5/8. 3 1/6 divided by 5/8. So in this one, we just need to change the first one to an improper fraction. 3 1/6 would be, what is an improper fraction? 19/6. 19/6 divided by 5/8. Now I have to remember I've got to change it from division to multiplication. So what should my problem be? 19/6 times 8/5, right? And then I can reduce. Can't always reduce, but I can reduce this one because the 6 and the 8 are divisible by 2. So this is going to become 3 and the 8 is going to change to 4. So multiplying 19 times 4. Times 4 is 76. And then 3 times 5, 15, right? So 15 divides into 76. How many times? 5 times. 5 times that 5, 25. I can't multiply today. It's 75, right? I do that right. So I get 15 1/5, huh? So 5. This is so slow. And 1, I erased my answer. Was it 15? Is that what we had? Must have been. It says I've learned this question. It thinks I want to be done, but I don't really want to be done, so I'm going to go down to the review in the chapter reference, mixed number division, and give you one last one to do on your paper if it comes up. So, 3 1/2 divided by 3 1/6.
3 1/6 to do this one?
Yep, 3 1/2 divided by 3 1/6. And you got
1 2/19.
1 2/19. So So you changed your 3 1/2 to 7/2. You changed your 3 1/6 to 19/6. Then you had to invert your fraction. So 7/2 times 6/19. The 2 and the 6 reduced down. You multiplied and got 21/19, which is 1 and 2/19. Alrighty.